Hello guys, again, sorry that I can't be there today, but we're going to go ahead and do part 2 of the conjugate root notes, and this is where we're going to learn some other skills that we could do, and this one's going to deal with writing equations. All right, so part C, writing equations. And remember that our conjugate roots come in pairs. They have to come in pairs. And so we're going to work off of intercept form, which actually, right? So this would be the quadratic, except that we can now add as many different factors as needed. But also keep in mind that we might have multiplicities to deal with when you're doing a polynomial equation. Okay, this is where P, Q, or W are solutions. Now those could be any solutions. They don't have to be real. So they could be real or imaginary. All right, let's do some examples. Given x equals 4 and x equals 2 are solutions and the y-intercept is 4. Okay, so I've given you two solutions. I've given you the y-intercept, and here's a look at the vocab, right? And equation with rational coefficients. This word right here, rational coefficients, is what means that the imaginary and radical roots come in pairs. Now in this example, I don't have radical or imaginary roots, but I just have real roots that are already rational. So write an equation with rational coefficients. All right, y equals a. Notice that we're using that 5.3 and that 5.2 connection. We're turning our zeros into factors. Notice that it's opposite. Cool. This should look like the last unit with quadratics, and the y-intercept is 4. So that's going to be the point 0, 4. And I'm going to substitute to find the a value. Okay, so a is 1/2, so let's go ahead and write the final answer. Now, it didn't say which format to leave it in, but this would be the factored form, and I check it has all rational coefficients. Given x equals I and x equals root 2, okay, are, I'm going to change the word, roots. Roots and solutions are the same thing. And y-intercept is 10. Okay, write an equation with rational coefficients. And I'm going to add directions here, rational coefficients in factored form. Okay, so I'm going to take my information. I've got, right, I'm highlighting because it's an imaginary solution, and I'm highlighting because it's a radical solution, which means that I need to figure out the conjugates, and I'm just going to write them, separate them out. X equals root 2, x equals negative root 2. Okay, now that I have all four, I'm going to go ahead and turn this into factors. Okay, this is the 5.3. I've got to turn them into factors. X minus I, x plus I, x minus root 2, x plus root 2. And when you have all these different factors, you need to multiply the conjugate pairs first. Because when you multiply conjugate pairs, then you end up with rational coefficients. So you've got to do the conjugates first. Okay. Now, I'm running out of space here a little bit, so let's see what we can do. Squeeze a little extra paper in here, make it work. All right. First, outer, inner, last. Okay, so that gives me x squared. Ooh, canceling. Okay, minus I squared. That's actually plus 1. Okay, so there's the first factor. Notice that those are rational coefficients. Now, I'm going to do, okay, this one. First, outer, inner, last. Okay, root 2 times root 2 is 2. And conveniently, as expected, I am left with x squared minus 2. Okay, this is my factor, x squared minus 2. All right, now I did forget one thing here. And so I'm going to write this in, y equals okay, a, I forgot my a value. All right, but now I have factors with rational coefficients. They're just not linear factors, but they're still considered factors. And up here it says the y-intercept is 10, so that's the point 0, 10. And before I have the complete answer, I need to plug in and find my a value. Okay. All right, 10 equals a times negative 2. All right, y equals negative 5, x squared plus 1, x squared minus 2. This has factored form. Okay, they're just two quadratic factors, factored form, and I look at my coefficients, and they're rational coefficients. Okay, now for the goodie. We're going to focus on this skill of multiplying rational coefficient, irrational conjugate roots together in order to get rational coefficients. Here goes. Given x equals 3 plus I and x equals negative 2 minus root 5. All right. Our solutions right and equation that goes through 0. Let's see, 0. $15. Okay. With rational coefficients in factored form. Notice how I'm telling you how much to multiply. All right, I'm going to start by identifying my roots that have conjugates. And so both of them are going to have conjugates. And I want to write them both right here. Notice that it's just the sign on the imaginary part that is changing. All right. Now, this is the 5.3 part. Now we need to turn them into factors. Okay. Opposites. Now, in order to help me do this correctly, I'm actually going to subtract these from both sides. This is actually the factor. Notice how it's opposite positive 3 and opposite positive I. Okay, so I'm going to subtract these. Look at that. Okay, the subtracting helps me. It's kind of like working backwards. Right, I'm not solving, I'm going from the solutions back to the factors. Okay. All right, plus 2 plus root 5. Okay. When I do this, it's helping me work backwards to the factors. Look at that, minus minus, both signs change. Minus plus means it's going to be plus minus. Whew. Okay, so you've got two sets of conjugates here, and you have to multiply your conjugates first. Now, I showed you one way to do this. I'm going to give you another visual that could be helpful because everybody likes to organize in a different way. And some of you might be familiar with the box method. So we're going to make this like this. Okay, it's a 2 by 2, but that top left corner is bigger on purpose. I'm going to just lightly add this up. Okay, let's line it up. X minus 3 minus I, x minus 3 plus I. And we're just going to, this is one way to help you distribute. Okay, kind of like your Punnett squares. I like to include my signs when they're positive. Minus minus is positive, okay? Okay, I'm going to do a little highlighting here. This is kind of like foil. See this? I'm going to group it up. I can't see that blue. Let's get that a little more blue. There it is. Okay. All right. So this is the box method. Notice that these pieces that I didn't highlight, they actually cancel out. Okay. So I highlighted the pieces that were left. And I'm going to show you the foil and the grouping. I grouped this. Notice that it's the same thing. So it's first, outer, inner, cancel. Look at that. X minus 3 times positive I. X minus 3 times negative I. Cancels out. Okay. Minus. Last. The foil with the grouping is a quick way to recognize. Okay, those things cancel out. That's it. Now, should you eventually be able to skip, oh, this is a minus, minus, okay, now remember, I squared is negative 1, so this actually becomes plus 1. Eventually, you should be able to skip to first, outer, inner, last, knowing that the two middle pieces cancel out. Now this box helps. Okay, so x squared minus 6x is plus 9, so it's actually plus 10. All right, there's my first factor. Remember that the goal here is to focus on how to multiply these conjugate roots quickly and efficiently. So I gave you the box method. I gave you the foil method. You could distribute, but you should be able to confidently pick one of these two methods to end up with this trinomial. Luckily, this method works with any roots. I like to kind of compensate here, darken that in, and then just because it helps me a little bit. Okay, let's line it up. X positive 2 positive root 5. X positive 2 minus root 5. Okay, so let's do our distribution. X squared plus 2x plus x root 5 plus 2x plus 4 plus 2 root 5 minus x root 5 minus 2 root 5. Okay, minus 5. Okay, what parts are canceling out? Cancel out. Cancel out. So what am I left with? I'm left with this perfect square right here. Perfect square, which comes from x plus 2 being multiplied to x plus 2. What am I left with? I'm left with this, which comes from this part. Okay, so there's the box, the visual. Now I'm going to show you the foil. Okay, first, outer, inner, cancel out. last minus 5. Right? You can do the box method, you can do the FOIL method, but make sure you recognize how to get from these conjugate roots all the way to the appropriate trinomial. So this is x squared plus 4x plus 4 minus 1. Whew, okay. What's our point? What's our point? Boom, 0, 15. So let's substitute. Okay, can do this. Got my 0 in there. 10, negative 1. Okay, so 15 over negative 10. Okay, so that's a minus 3 halves. All right, y equals negative 3 halves This is it. So let's check it. Let's describe. What do we have? We have rational coefficients, factored. Yes, that's as much factoring as you can do because both of these polynomials are prime. Okay, your takeaway from writing equations today, besides that there is a connection to problems that we solved previously, is being able to multiply these roots and these factors that have 3 pieces to them. I want you to be able to do it effectively and efficiently. Okay, that might mean doing the box or it might mean doing the FOIL method. The only thing that we haven't talked about yet is what do you do with multiplicities? Let's find out. Given x equals 2 is a double root, okay? And x equals 3i is a solution. Y-intercept is 0, negative 18. All right, look at the directions. Write equation with rational coefficients in factored form. Okay, let's start by x equals 2. What? Yeah, double means twice. X equals 3i. Oh, I better highlight that. That is an I. And so I automatically have to write in the conjugate. The reason we're including the conjugate is because I'm supposed to have rational coefficients. The only way to get rational coefficients is to have the conjugate. So now let's turn these into equations. X minus 2, x minus 2, x minus 3i, x plus 3i. And I'm going to multiply the conjugate first. Notice I'm not multiplying that. I'm just writing it with the multiplicity. Okay. I don't need to group anything here, but I am going to just highlight it. And I'm going to FOIL. So first, outer, inner, cancel. Outer and inner will cancel with conjugates. Last, minus 9i squared. All right, so I squared is negative 1, so it's really just going to change the sign here. So y equals a x minus 2 squared, x squared plus 9. Okay, Now I need the a value. Okay. Minus 18, a. All right, be careful because this is negative 2 squared, which is positive 4, and this is a 9. Okay. 36. And we divide by 36, and we get minus 1/2 equals a. All right, minus 1/2. Wow. All right, so I'm going to describe my answer just to make sure. This is factored form, and it has rational coefficients. High five. You guys did a fantastic job.